Hi everyone, this lesson is for Algebra 2 honor students. This is your first semester final exam review. So good luck, let's get started, and let's see how we do, okay? All right. So obviously we have a lot of things to cover, but resilience is so important, and using your knowledge to the best of your capabilities and find your inner strength are three things that I really believe in. So, all right, think about that while you're going through the problems. So the first problem deals with functions and whether or not something is a relation or a function. A relation is just as small as an ordered pair. So a single point can be a relation, all right? But a function definitely can be a relation, but also a function has to pass a straight line test, which means that for every one value of x, you can have one and only one value of y. So what you get when you plot these points here is you're going to see these points right here, for example, -1, 2, and then what is that? 0, 2. And then you have 1, -3, so 1, -3. And then we have 2, and this looks like this goes to -2. -2, and then we have 6. I think that's 6, could be something else, and I don't know my glasses on. That might be 8. 8, and then 3. So what we have here is -1 up 2. You have 0, 2. You have 1, -3. You have 2, -2, and you have 8, 3. Maybe that's 8. And so what you're seeing here is this. Is this a function, yes or no? This is a yes, for sure, because for every value of x, you have one value of y, meaning I can draw a straight line down any one of these points like this, and I'm only intersecting each of these points one time along that x value, right? So definitely this is a function. And the reason, because for every one value of x, you have one value of y. What are the inputs? The inputs are our domain, okay? And in this case, our domain are all of these x values. If you see any repeated x values, you would know, though, that it's not a function, right? The domain, it would be these points, so it'd be -1, 0, 1, 2, and 8. So you would write it like this. You go domain equals, and then you would put the values in like this all the way to the end. The outputs are our range, and these are our values of our range here. And so also you would write it like that. Range is equal to, and you'd put the values. And you don't have to do any repeating values here. So like if I have two values that are -2, I'm not going to put -2, -2. So you would just say -3, -2, etc., all the way until you're done. For this problem here, I can tell this one is not a function, because right at the very, very first, it looks like it says -1, and it goes to 3. And then it looks like it says -1, and then it goes to 4. Okay, so right now, if you're at -1 and you go up 3, you're here. But then if you go -1 and you go up 4, you're here. And right now, we know this is not a function because, number one, look, it doesn't pass the straight line test. I have two intersection values. That means no way it's not a function. And our inputs, again, those are our domain. These are these values of x, and my range are my values of y, or my output. For this problem here, it's asking me if I were to graph these points. So I go over 3, up 4. It's just one more of these. So obviously, everything that are in these slides are on your final. Okay, and if you find that there's something that, hey, I already know this, go ahead and fast forward. That's completely fine. So 2, 1. So we're over here, up 1. We go over 4, -2, and then we go over 5, and we're up 1. So this is definitely a function. This is a yes value, because again, I can draw a straight line, and I'm only intersecting each at one of these x values one time. As soon as I'm intersecting twice, that would be no, okay? It would not be a function, but this is a function. And the reason for, you would write, for every value of x, there is one and only one, and that's actually, it says one and only one value of y, and that's really the definition of the function. Okay, there is only one and only value of y. So find the domain. The domain are all the values for x. So you would say the domain, you would write it like this, and you would say the domain, and it's always nice to put it in, order, where you could say, let's see here, we've got the lowest value, which, what is that, 2, and then 3, and then 4, and then 5, and then close the solution sets. And then for the range, you would write 4, let's see here, it goes -2, and then it looks like 1 twice, but we only write it once, and then 4, and then we're done. Okay, cool. Next thing. Given the function right here, we have f of x and we have g of x, and your job is to find f of g of 3 and g of f of 2. And so, on the final exam, there's going to be multiple problems, and every one of the finals are going to be different, because for each set of problems, we're going to have, 3 or 4 or 5 problems. And so every person is going to have a different version of that. So just make sure you guys know this stuff solid, okay? So we have f of g of 3. That's what that looks like. So that means first we got to plug in g of 3. So that means we got to plug in 3 into g. So we're going to go g of 3, which is the opposite of, now put the parenthesis, put the value that you're plugging in parentheses. So that was going to be 3 squared and then add 5. So this would be -9, add 5, and so that's -4. So now I'm going to take -4 and I'm going to plug it into the f part of the equation, right? So now I'm going to go f of -4, and that's going to be 2 times -4, and then add 3. So that's -8 plus 3, which is -5. So I would write, therefore, like that, f of g of 3 is equal to -5. And that's my final answer for this right here. For this problem here, this is asking me to plug in g of f of -2. All right, so that means I got to plug in -2 into f first. So here's f. So we're going to go f of -2 is equal to 2 times -2 and then add 3. So we get -4 plus 3, which is -1. So now I'm going to take -1 and plug his, because this value right here now is -1. So we're going to go g of -1. And so that's going to be the opposite. And like I said in the other problem, take that value that you got and make sure that that's in parentheses so that it distinguishes from any value that's outside that could be like the opposite, right? So we have -1 quantity squared and then add 5. So this here is 1, but when I do the opposite, that's now -1 plus 5, which is 4. So that means that, therefore, g of f of -2 is equal to 4. And then you would just box that up, okay? Given the function below, yes, one of the questions is going to be asking you to find the inverse. And so remember, to find the inverse, you're going to take your f of x equation, this is f of x, and you're going to make that y, because f of x is y. It's just f of x. By them saying f of x, they're saying this is a function. That's why they have f of x. If you have y equals, that doesn't necessarily mean it's a function. It just means it's an equation, right? A y equals equation. But by them saying f of x, that's solidifying, hey, whatever I'm giving you, that's a function. All right, that's the reason that they use f of x instead of y. Okay, so right now we have y equals 3x plus 2 over x minus 5. So the rules for finding the inverse is that you take the x and y values and you flip them, right? You switch them out. And then you solve for y. So we're going to go x is equal to 3y plus 2 all over y minus 5. Oops, yeah. Okay, now we're going to cross multiply, okay? And when I do that, I'm going to go x times the quantity y minus 5 is equal to 1 times the quantity 3y plus 2. And 1 times anything is just that value. So we don't even really need the 1 times the quantity. I'm going to distribute this x here. So I'm going to distribute between here. So I get xy is minus 5x is equal to 3y plus 2. All right. I notice that I have y's on both sides. And remember what your objective is. Your objective is to, right, from the beginning, switch your x and your y, solve for y. So we want to get the y's on the same side. So I'm going to take this 3y, move it to the other side. So I get xy minus 3y, and I move this 5x over to the other side, and I get 5x plus 2. Then I'm going to factor out a y, and when I do that, I get x minus 3, and then that equals 5x plus 2. I'm going to divide out the x minus 3. So I get y is equal to, and by doing this, now I have y by itself, so now it's y inverse of 5x plus 2 all over x minus 3. So this is my equation right here. And a lot of times people will take the y to the negative 1, which is y inverse, and they would flip that into f of inverse. That's what that is, right? And then say, okay, that's 5x plus 2 all over x minus 3. Now, a question that you could be asked, not saying you are, I'm just saying you could be asked, is that, what's the domain and the range, or the domain for f of x, or the domain for, f inverse of x, right? So just remember that what x can't be on the denominator. So right here, see that x minus 5, that value cannot be 0. So that means that x cannot be 5, which means that at 5, 1, 2, 3, 4, 5, at 5, I have an asymptote right there. Now, not sure if you went over this in class. We just briefly went over this, but just note that we actually have also, based on this right here, a horizontal asymptote at 3. So that means that at 3, now you guys can graph this on Desmos, and so this shouldn't be a problem. You can also use your graphing calculator. So what you're looking at is you have a graph that does this, and then a graph down here that goes down here. Now, if I want to know what my y-intercept is, right, I would set x equal to 0. So let's think about that. If I wanted to be more specific for a graph, I would go, if I want to find the y-intercept, I would set x equal to 0, and my y-intercept is negative 2/5. So it actually goes through here, right? And just a little thing in the back of your mind, if I want to know what my x-intercept is, right, I would set the numerator equal to 0. So I've got 3x is equal to negative 2. So x equals negative 2/3. So that's right here. So this is basically telling me, yep, your graph is doing this, and it's doing this. So if I wanted to find my domain, I'm going to go negative infinity, right, to 5. So that would be negative infinity to 5. And then I would continue on after the 5, right? And I would go 5 to infinity. And that's how that would be my domain for this graph. And remember, the range, this is my domain. And remember, the range is going to go bottoms up, right? So my range is going to go down from the bottom, which is negative infinity, to, it's going to stop here. Where was I? 3. And to 3. And then it's going to continue at 3 and then go to infinity. So if I wanted to find the domain and range for my inverse, right, remember, they're flipped. So my inverse equation would be my domain. So that would be here. My range is my domain. So for this value, my range would be my domain. And then my domain would be my range. So they're opposites when you're dealing with an inverse. Moving on to functions and lines. Remember the three forms of a linear equation. You've got standard form, where the a value has to be positive, and it has to be, it's a positive number, and it has to be an integer, which means it can't be a fraction. Slope-intercept form, where you solve for y, and point-slope form, which is the most popular one, because most of the time you're given a point and a slope, so then you would put it in point-slope form, okay? The first equation that we have here is find the equation of a line that goes through this point and parallel to this. Parallel lines have the same slope, point, slope. So just keep in mind, though, that a lot of kids will mess up as far as when they, why am I saying H here? HK is the point that they gave me. So this is HK right here. And when you're noticing that, you should notice that this minus sign here and this minus sign here basically means they're taking the opposite of whatever that value is, right? So to put this in point slope form, this is going to be y minus 8, because this is positive 8. So it's the opposite. That minus means the opposite. So y minus 8 is equal to my slope times x minus 7, actually. And so therefore, now I have 7. Now, I do need to find my slope. And I'm going to steal my slope from here. So I'm going to solve for y. So I get 3y is equal to 2x plus 12. I'm going to divide everything by 3. I get y equals 2/3 x plus 4. My slope is 2/3. So I'm going to plug that in right there. So I'm going to erase this. Gone. And then I'm going to put my slope in, because parallel lines have the same slope. So this slope is going to be 2/3. Now, if they don't ask you which form to put it in, you've got point slope, you're done. But if they say put it in slope intercept form, then you would need to solve for y. So let's just do one of those. So we're going to go y equals, I'm going to distribute this 2/3, and I'm going to get 2/3 x. minus 14 over 3. And remember, a lot of kids get confused on this because when you're multiplying fractions, the numerators get multiplied with the numerators and the denominators get multiplied with the denominators. That's what you need to remember. So that 2 gets multiplied by the -7, the 3 gets multiplied by the 1. And then don't forget this -8. We're going to add 8 here. So we have y equals 2/3 x. Now, I need to combine these two terms. They're both values of, so that they're both a constant. So we're going to add those together. So I need a common denominator. It's going to be whatever the fraction is on the other term. So it's going to be 3 over 3. Because remember, you cannot change the problem. But by multiplying by 1, I'm not changing it. I'm just kind of manipulating it, right? Okay, so we have 24 minus 14 is 10, and that's over 3. So this is, most of the time, this is the form you're going to be asked. This is slope-intercept form. Just occasionally, you're going to be asked to put this in standard form where the x and the y are on the same side. So we'll do one of those and bring that over negative 2/3 x plus y is equal to 10 over 3. Now, this is like a lot of issues. Number one, it's not a fraction, or it's a fraction. We can't have a fraction. Number two, it's negative. So we're going to multiply the entire equation by -3. And in doing that, that's going to get rid of the fraction. It's going to get rid of the negative value. So here we go. -3 times this. 3's are going to cancel. Negatives are going to cancel. I get 2x. -3 times y is going to give me -3y. And -3 times this here, 3's are going to cancel. I'm going to be left with equals -10. And that's my answer right there. And these are all the same lines, right? These aren't different lines. It's just a line in different forms. And the reason, I mean, you know, realistically why people would even use this form right here, which is standard form, is because they would be graphing by intercept. So for example, you know, if I wanted to find the x-intercept, I'd set y equal to 0, right? Meaning I would cross this out. And so my x-intercept is -5. So that's going to be right here. Okay. And then if I want to find the y-intercept, I would cross x out, right? And I'd get y is equal to what, 10/3? What is that? 3 and something. So I would then 3 plus and 3 and something is up here. So realistically, this is why people use standard form, so that they can graph that pretty quickly, right? I could also graph it point slope. You have a point, you have a slope, you can do it that way too. For this problem, I want to write the equation of the line that has these two intercepts. Intercepts are always the best way to do things. You've got 0, 3, which is here, and then you've got -5 here. And so realistically, we have a graph. Pick one of the points. It doesn't really matter. I'm going to pick the 0, 3 first. So we're going to go put it in point slope form. Y minus 3 is equal to my slope. Now remember, my slope, rise over run. So this is going to be up 3 over 5. And remember, if it's going up on the right arm up, that means that it's going to be a positive slope, right? So up 3 over 5, so that's 3/5. And then, so that's times x minus 0. Now, just solving for y, I'm going to get y equals 3/5 times x. I'm distributing. And then times 0, that's gone. And then add 3. So this is my slope-intercept form. Technically, we would be done. But if you chose this point instead, you would go y minus 0 is equal to my slope, again, 3/5, times x plus 5. Remember, point slope, you take the opposite value of that x. Solving for y, I'd get y equals 3/5 x plus, what is that, 15 over 5. 15 over 5 is 3, so plus 3. So look, what I'm trying to say by doing this twice is that no matter which point you choose, as long as it's a part of this same line, you're going to get the same slope equation. The point slopes are going to be different, but that's why everybody asks for the slope-intercept form, is because at some point they're going to be the same value, right? So why not ask that part? Last one of these, and this one is saying, here's my new point here. Whoops. Here's my new point, 4, 5. And so I'm going to set that into point slope form. So I'm going to go y minus 5 is equal to my slope times x minus 4. But they want the value that's perpendicular, right? So remember, perpendicular means whatever my slope is, I'm going to take the opposite and then the reciprocal. So I'm going to graph, this is like -1 and then up 3. And then I've got 2, 9. So, you know, completely your choice. You can add up and over to find the slope, or you can use the slope formula, right, which is the change in y over the change in x, which basically means subtract your y's. So let's see, we got 9 minus 3, and then subtract your x's on the bottom. So that would be 2 minus, and then negative 1, which makes 2 plus 1, which is 3. 9 minus 3 is 6. 6 over 3 is 2. So my slope is 2. But they want it perpendicular. It's perpendicular, which means basically it looks something like this. You know, I'm not saying this is where it is. I'm just saying it's going to be somewhere along this line, which we don't care where it is. We just know that it's going to be perpendicular, which means that my slope, which is 2 over 1, I'm going to take the opposite and the reciprocal. So that's going to be negative 1/2 is going to be the slope of the line that's perpendicular. So I'm going to take my slope and I'm going to plug it in right here. And so that value here is going to be what? Negative 1/2. And so this is point slope form. You can leave it at that, you're done. Or you can solve for y, right? And then that's, like I said, that's the most, case scenarios when everybody asks for that. So let's just do that. Y equals negative 1/2 x. That's that. And then I'm going to multiply numerators and denominators. And the denominator for that is 1, right? So we're going to get 4 over 2, which is 2. So plus 2 and then plus 5. So that's going to be y equals negative 1/2 x plus 7. So this would be my slope-intercept form of that equation. So moving to quadratics, right? We're just cruising right through. You remember, do any of these slides look familiar? Okay. All right, so find the zeros. Finding the zeros is actually asking, several things. There's different ways to write zeros, right? Realistically, finding the zeros is the same thing as saying finding the solutions. It's saying find your x-intercepts. These are all the same thing, right? X-intercepts, what's the other one? Roots. All of these are saying find the zeros. So you should know that if you want to find the x-intercept, right, you need to set y equal to 0. Because if I wanted to find the y-intercept, right, what's the y-intercept for this equation? I would set x equal to 0 if I wanted to find my y-intercept. So that'd be 0 way up here, 34, right? Okay, so in order to find the x-intercept, I need to set y equal to 0. F of x is y. The reason they told me it was f of x because they're saying, hey, this is a function, by the way. So we have 0 equals x squared plus 10x and then plus 34. And, definitely you have so many ways to solve this. You can use factoring. I don't recommend that for this problem. You can do factoring. You can do quadratic formula. You can complete the square and then square root both sides. You should have the calculator formula on your calculator. That's what I would do. And I just want to remind you of that because so important that you have that available to you. Okay. I will try to post that formula, the formula for that, again, the programming, but it's on one of the slates. You guys should be able to go back and find that. We're going to use quadratic formula first. So we're going to get x is equal to, and I know that a is 1, b is 10, and c is equal to 34. And where did those come from? That came from y equals ax squared plus bx plus c. A is in front of x squared, b is in front of x, and c is by itself. All right, so we have x equals the opposite of b, so that's going to be negative 10, plus or minus the square root of b squared, which is 100, minus 4 times a times c, which is 34. And this is all over 2a. A is 1. So 100 minus, what is that? 4 times 34. Oh boy, I can't see. So 4 times 34 is 136. So that's 100 minus 36, which is negative 36, right? So we have x equals negative 10 plus or minus the square root of negative 36 all over 2. Now, what you should remember about negative 36 is that negative 36 is the same thing as saying the square root of negative 1 times the square root of 36. The square root of negative 1 is I. Square root of 36 is 6i, right? Okay, so what we have now is x equals negative 10 plus or minus 6i all over 2. Now, I will be frank with you guys in that you should know that most of these problems should be put in what we call a plus b plus or minus, right? bi form, which means that you're separating them out, right? So thankfully in this problem, I actually can cancel out, see that 2? So this is what I'm talking about. This would be negative 10 over 2 plus or minus 6i over 2. See how I split those up? That's what I'm looking for. And that's what you're going to see on the test. So this is going to look like negative 5 plus or minus 3i. And so this right here would be my solution. Now, what that tells me, people, is that my graph is floating. It's a floater. Yeah. All right, remember? And so what that means is basically that my graph is like floating up here. It's not going to cross my x-axis because my solutions are imaginary, right? And I could have figured that out by right here at negative 36 because that's my discriminant, right? Remember that? B squared minus 4ac. And if that value happens to be negative, that means your answer is imaginary, no real solution. So it's a floater. It's floating. All right. We found the zeros. Putting this in vertex form, we know that we have negative 10, we have a vertex, right? Or excuse me, a y-intercept at 0, negative 10. So in order to find this in vertex form, right? This is the cool vertex form, right? We're going to complete the square. And so in completing the square, a couple of things have to happen. Number one, see this negative 10, I'm going to move it to the other side. So we have y plus 10 is equal to x squared minus 6x. Now, additionally, your x squared term, right here, your x squared term, that constant, the number in front, which thankfully is 1 here, but if it isn't 1, if it's a negative sign, or if it's a number, you actually have to factor that out in order to be able to complete the squares, right? So totally fine here. It's in good shape. So we're going to complete the square. Completing the square means we're going to take the b term, whatever that is, we're going to take half of that. And then we're going to square that quantity. So half of negative 6, right, is negative 3. And then squaring negative 3 is 9. So I'm going to add 9. But remember, this is actually an equation, which means that whatever I'm doing, because it's an equation, I have to do it to both sides equally, both sides. So if I'm adding 9 here, I'm going to add 9 here, which means on the left, I get y plus 19. And on the right, I'm going to factor this. I'm going to get x minus 3 quantity squared. And you remember, always, it's whatever is in this little parenthesis here. It's the square root of that goes here, and then the square root of that goes right there, always. If there's a negative sign, that's negative. Easy. So we have y equals the quantity, x minus 3, quantity squared, and then minus 19. So this is what we call vertex form, right? Gives us our vertex. Our vertex is the opposite of this value. You see that? So that's going to be 3, comma, and the same value here. So negative 19, opposite same. So that's my vertex. So over 3, down 19, way down here, which basically means that my graph comes up from there and does that, okay? Another thing that you need to be aware of is that you should know what the axis of symmetry is, and the axis of symmetry is always going to be like this, written like this: x equals negative b over 2a. Now, if this looks familiar, it should, because negative b over 2a happens to be your x coordinate. So you would write the axis of symmetry like this: x equals 3. That's your axis of symmetry. And in case you forgot what that looks like, that's just this line that goes right down there, right? Cuts that graph in half and makes it symmetrical. I want you to convert this to vertex form, which basically means we're not using the vertex shortcut. We're going to complete the square to solve. So 7 is going to go to the left side. So we're going to go y minus 7 is equal to 2x squared and then minus 20x. Just looks like my y-intercept is at 0, 7, so right around here. I know I'm crossing my axis. Now remember, to complete the square, this x squared term has to be 1, which means that I do need to factor out that 2 before I complete the square. So in doing that, that becomes negative 10, right? So we're going to take half of the b term, which is this 10. Half of that is 5, negative 5. But when I square that, I get 25. So I'm going to add 25 to both sides, but realistically, I'm not adding 25. Remember that if I factored out that 2, that has to go back in when I add to the other side, because that's actually on the right 2 times 25. So what I'm adding to the left side is 2 times 25, which is 50. Whoa. And so 50 minus 7 is 43. So we get y plus 43 is equal to, now factor that, 2 times the quantity x, and then that's going to be 25. Square root of 25 is 5. This is going to be quantity squared. Because I have one negative, that's negative. And so vertex form is going to be y equals 2 times the quantity, x minus 5, quantity squared, and then minus 43. So that this is vertex form. It means that my vertex is going to be 5, comma, the opposite of that value, and then this is going to be negative 43. So over 5, way down here at negative 43, and my graph is just going to like come up slowly like this, and then on this side as well. And then this is going to be my axis of symmetry is actually going to be x equals 5 is my axis of symmetry, okay? Moving to imaginary numbers and in quadratics, right? What you're going to see is complex numbers. Complex numbers are real numbers and imaginary numbers. So a plus bi, that's a complex number. A is my real number and bi is my imaginary number. And so what's going to happen here is I've got just two examples here. And what needs to happen is I need to lose the I. You cannot have an I on the denominator. So in order to get rid of that I on the denominator, I'm going to multiply both sides, the top and the bottom, the numerator and the denominator, by just I. Because by doing that, I'm going to distribute, I'm going to get 3i plus I squared all over, and then this is going to be negative 4i squared, okay? Okay, so what you need to do here to simplify is that I squared is negative 1. So realistically on the top, I have this right here being negative 1. So it's going to be negative 1 plus 3i. And then on the denominator, this also is negative 1, right? So we have negative 4 times negative 1, which is 4. So this right here is my solution. But if I wanted to put this in a plus bi form, I would then write it like this, negative 1 over 4, and then plus 3i over 4. So I would split those values up, because that's a plus bi form, okay? All right, for this problem here, you're going to multiply by the conjugate, and the conjugate is going to be 5 plus I, all right? 5 plus I, like that, all right? So when we distribute on the top, we're going to get 6 times 5, which is 30, and then 6 times I, so 6 times I is plus 6i. And this is all over, and now I'm going to FOIL on the denominator. So 5 times 5, 25, and then 5 times I is plus 5i, minus 5i, and then this is minus I squared. So then what I have is 5 i's are going to cancel. So do I need to write that? Probably not, because you should know that. But what I have left on the denominator is 25 minus I squared, right? So minus I squared is negative 1. So now going back, I've got negative makes plus. So I've got 26 on the denominator. So I have, splitting these up, right, to put this in a plus bi form, I'm going to have 30 over 26 plus 6i over 26. And yeah, I would just reduce as I can, right? Looks like I could divide by 2, and I get 15 over 13 plus 2 divided by 2 would be 3i also over 13. And so this would be my a plus bi. That's my answer, simplified. For this problem here, very similar to the other one, except for when I multiply by the conjugate, I'm multiplying top and bottom. And just remember that if you see this like on your SAT or something like that, right, a lot of times you're going to see on the denominator, you're going to see something like this, negative 1 plus 4i instead of what I have here. And in that case, when I multiply by the conjugate, it's negative 1 minus 4i. So I want you to be careful, right, when you see that negative 1 out front. That is not part of the conjugate. The conjugate is just that middle term that you're flipping, that you're switching. All right, so just remember that. Make a note on this side. All right, so I'm going to multiply this by the conjugate, which is 1, right, over itself. So we're going to go 1 minus 4i over 1 minus 4i. And in doing that, right, the i's on the denominator should cancel out. I'm going to FOIL on the top, right? So I'm going to get 2 minus, looks like a minus 8i minus 3i, and then looks like plus 12i squared. And this will be all over 1, and then the negative 4i, right? And then the positive 4i are gone. They are going to cancel out. And then I get minus 16i squared. All right. So looking at the top, I see I squared is negative 1. So this is 2 minus 12, which is negative 10. And then negative 8 minus 3 is negative 11i. And then on the denominator, I've got 1. And then this is negative 1 here. So 1 minus 16 times negative 1 is plus 16, which means that's 17. Which means that now that my values are going to be negative 10 over 17, and then minus 11i over 17. Because look at the directions. Whoops. Look at the directions. The directions say put your answer in a plus bi form, which means, yes, you need to split those apart. Okay. Next term is talking about polynomials. Okay. This is really important because we did spend quite a while on polynomials, and just knowing that the definition of a polynomial is basically the sum of the terms of, where each term is raised to some number, has a power. You cannot have a fraction or negative exponent. So meaning there's no variables on the denominator, which would give me a negative exponent. So like 5x to the negative 3 would be 5 over x to the third power, not a polynomial. Other things that are not polynomials are square roots of x, not a polynomial. Absolute values of x, not a polynomial. And then, of course, the x is on the denominator. A polynomial graph has to be smooth, okay? So meaning it's going to be like this. It's going to be continuous. It's not going to have any sharp edges like an absolute value, right? Which is looks like a V, right? A 1 over x, that's one of those graphs that looks like this, right? And that's not continuous. I've got asymptotes that break up my graph. A square root function definitely is not continuous, right? Starts at one point and goes over. It's not continuous. It doesn't go on forever. So a polynomial has to be, something that is continuous. Now, two things that we're going to be asking you about polynomials. Number one is their degree. I'm going to ask you about the degree, okay? Secondly, I'm going to ask you about what we call the LC, leading coefficient, all right? So in this problem here, it looks like I have 4 terms, right? 4 terms. I'm not asking you that. A 4-term polynomial is what we call a 4-term polynomial. 3 terms we call a trinomial. 2 terms we call a binomial. 1 term is a monomial. I'm not going to ask you that. I'm going to ask you for the degree and the leading coefficient. The leading coefficient is attached to the variable that has the highest degree. The leading coefficient is attached to the variable that has the highest coefficient. So in this case, this is x to the 0, definitely not the highest coefficient. That's to the 1, second power, third power. This is my highest x. This is my highest degree. So we call that a cubic, by the way. And so look at the leading coefficient. The coefficient is the number in front of that variable. So the leading coefficient is 1. So you would say LC is equal to 1. You would also say that the degree of this polynomial is cubic, or to the third power. Third degree, it's cubic. When you're adding polynomials, okay, it's always going to be the highest degree. However, when you're multiplying polynomials, remember how to multiply variables, right? If I have x to the second times x to the fourth power, keep the base, add the exponents. So that's x to the 6th, right? So that would be a 6th degree. So as soon as I start multiplying polynomials, I'm now adding the exponents instead of just keeping them separate. So be careful on that. What you see here is more polynomial functions, right? We got a leading term that's in front of the highest power. So for this problem down here, 2x squared plus 1, the highest power, because this is going to be, all coefficients have a variable that's like x to the 0 power. See this squared right there? That's the second degree. That means a second degree polynomial. Second degree polynomial is what we call quadratic. And yeah, you guys should know that. We also have the leading coefficient. That's in front of the highest power. Well, the highest power that I'm adding, right, is the squared power. So that my leading coefficient is equal to 2. for this problem here on the right, it does look like, oh look, this power is higher than that, which means that this is now my leading term, which is going to give me my leading coefficient. So my leading coefficient is equal to 3. My degree for this term is 6 degree. And we actually don't have a name. A first degree is what we call linear, right? First degree, do you guys remember this? First degree is linear. Second degree is quadratic. Third degree is what we call cubic. Fourth degree we call quartic. Fifth degree we quintic. And 6th degree and higher, we don't actually have a name for it. We just call it 6th degree. Polynomials and not polynomials, just kind of review with this. If you're not unsure about polynomials, you're like, blindsided. Yep, new word for me this week. So if you have polynomials, you've got 3x. These are all polynomials. So you've got 3x to the 1, that's a polynomial. X to the 1, polynomial. That's a first degree binomial, right? That's a first degree monomial because it's one term. This one, be careful. See this x here? It's not on the bottom. This actually looks like 7x over 9. That's what that should be looking like. This is x to the 1 power, so that's not the highest power. So I'm not even looking at that, okay? I'm looking at y squared, which means it's quadratic, and my leading coefficient would be -6. For this term, now this is a good example right here. Look, I've got 3 terms. X, 1, 1, so that's the second power, that's a quadratic. 2, 3, 4, that's a fourth term, that's a fourth power. 1, 2, 3, that's a third power. So this is out. This one is now my highest power. Y to the 1, x to the 0, those don't count. That's my highest power because that's 2 plus 1 plus 1 is 4. And so I have a 4th degree right there with my leading coefficient is equal to 3. For this one, they're both the same power, right? So it's a 5th degree, and I don't have a leading coefficient technically because they're both the same power. This is x to the 0 power, and that's 5. 5 my leading coefficient. Still a polynomial. It's a one term, and we just call that 5 a constant. And actually, this is a little definition for that. These are not polynomials. See that y to the -2? I know it's small. Sorry about that. Y to the -2, not a polynomial. You can't have variables on the denominator. No. This is also not a polynomial, x plus 2. Not only does it have a variable on the denominator, right? These look like this, right? Not continuous. 1 over x, same thing. Square root of x is a no, because that's just this, it looks like that. Not continuous, not a power, it's not a polynomial, all right? Okay, so these are polynomials, yes. All of these are examples of polynomials. I would ask you for the leading coefficient and the degree. So if I'm just adding, these are, see, add, add, add. These are multiply, these are add, add, add. These are multiply, these are multiply, okay? If I am multiplying, I'm going to be adding up the exponents. If I'm adding my polynomials, like in separate terms, it's the highest term, that's it. So 2, and this is x to the 0 power, so this is my highest degree. So this is what we call a 6th degree, all right? And then polynomial. And you could call it a 6th degree 1, 2, 3 trinomial, right? My leading coefficient is equal to -2. Take the sign in front, by the way. All right, for this one, I'm multiplying. So I have to add up my x powers. So this is going to be 1 times 3. So that's 3 of those, 1 of those, 1 of those. So now I have a 5th degree. Do you guys see that? Let me do this again. Okay, watch. You've got 3 x's here, 1 x here, and 1 x here. So that's 3, 4, 5. 5th degree. We call a 5th degree, we call that a quintic. All right. And my leading coefficient is going to be, let's see, what's in front of my x's. And I have to use, don't forget to use the powers, right? So this is going to be, there's nothing in front of that. So that's just 1 to the 3rd power, 1 to the 1 power, 1 to the 1 power times 2. So my leading coefficient in that problem is 2. I'm adding in this problem, so I don't look at, I'm not adding my exponents. If I'm adding terms, I look at the highest power. And my highest power is this one right here, fourth degree. Fourth degree, so it's a fourth degree, and we call a fourth degree quartic, Q-U-A-R-T-I-C. And then my leading coefficient also happens to be 4, because that's the number in front. All right, how are we doing? Okay, so the next value is this one right here. We've got 1 to the third power, so still 1. 1 to the 1 power, still 1, times negative 1. So in this case, my leading coefficient is negative 1. This is 3, 4, 5. Fifth power, also quintic. So that's a quintic. All right, and then lastly, I have this one right here, which I'm going to make this a little bit bigger. You're going to see something like this on the test for sure. I want to know the degree and the leading coefficient. So let's add our x's up. So we got 1 here. X to the 5th. Look at my x's in the back. Be careful. 5 here. So that's 6. 3 more. That's 9. And 2 more. So it's like this. X to the 1. That's 1. We have negative x. So that's an awful x. Really. Negative x to the 5th power. We have x to the 3rd power. And we have x to the 2nd power. So that's 2, 3, 4, 5, 10, 11. So this is an 11th degree. All right, that's my degree. And so now I need to take my coefficient. Now this is where you're going to get it. Okay, this is where you're going to get, maybe you're not going to get mixed up. I don't know. Okay, coefficients. Okay, this is negative 1. So right, negative 1 to the 5th power times the 4, right? That's so far this and this. 2, see the 2 to the 3rd power. So 2 to the 3rd power, I think you missed that one. And then this is 1 squared. So that's 1 to the 2nd power. So negative 1 to the 5th power is negative 1. And then I still have to times it by 4. And I still have to times that by, what, 2 to the 3rd power, which is 8. So I have negative 8 times 4. So my leading coefficient is equal to negative 32. Okay. Complex fractions, our favorite. Okay, so in complex fractions, what you guys need to remember is this, is that you can only divide one term by one term. That's it. One term divided by one term. And what you're looking at here is 2 terms divided by 2 terms. Can't have that. So what you need to do for this top, the first, just starting at the top left-hand corner, is we need to combine those 2 denominators, okay? And so in combining, just a second, there we go. In combining those denominators, we're going to multiply this term by 4 over 4. And this term here, I'm going to multiply by u over u. Because what that's going to give me is common denominator, 4u. And on the numerator, I'm going to get 4 times 4, which is 16 plus 25u. And this is all over 4u, okay? And this is divided by, now this is this divided by, this is the divided by. And then I've got 2 more terms on the denominator, okay? So now I got to get those together. So this looks like both of them has a u, check, and only one of them has a 2, so that needs a 2. So I'm going to multiply this by 2 over 2. So on the denominator's numerator, I'm going to have 1 minus 8, because that's 1 minus 4 times 2, over 2u, so 2u. And so now I'm going to divide this term, the top term, this term, divided by this term here. And remember, when you're dividing, you're actually multiplying by the reciprocal. So realistically, I'm going to have 16 plus 25u over 4u times the reciprocal, flip it, 2u over 1 minus 8, negative 7. So now, if there's anything you can cancel, seize the day. Now's the time. Cancel the u's are gone. 2 divides into 4 twice. So I have 16 plus 25u all over negative 14. Don't reduce anything, you're done. That 16 and that negative 14, don't touch that. The only way you could touch that or reduce that is if you saw something like this, negative 14 plus 25u over negative 14, right? And in that case, I could reduce the left side by 2, and I'd get what, 8 over 7, negative 8/7, which, okay, you can do that. Negative 8 over 7 plus 25u, oh, sorry, not plus, because I have to add that minus there, minus 25u over the 14. So this could be my answer as well. If I was taking an SAT and I didn't see this as my answer, this would be my answer right down here. For the numerator here, it looks like my denominators, lucky us, are exactly the same. So we have 6a minus 2a, which is 4 over a. Sorry, 6 over a minus 2 over a is 4 over a, divided by 3 over a squared. So again, this is just this top term divided by that bottom term. So I'm going to go 4 over a times a squared over 3. And, oh, look, I can cancel one of my a's out, right? That leaves me, this was a 1, so that's gone. So I have on the numerator 4a and then over 3 times 1, which is just 4a over 3. Go back and look at more complex fractions and practice those. There's also a lot of complex fractions that you can practice on something called CUDA Math. You can go there and just go and do a search engine called complex fractions, and then they'll have practice problems and then with the solutions, okay? These are asking me to perform the transformations, okay? So write the new solution. So just a note, if they wanted me to, if I started off with y equals the absolute value of x, right? That's a graph that looks like this. It's a V. It's like a line, right? Y equals x. Let's see that line like that. But because it's absolute values, these values that are down here actually don't exist, right? Because it's like they're bouncing off of that axis. So these are gone here, all right? Now, see this y minus? If you have a negative sign in front of, see that how it's in front of whatever parent function that you have, that means it's a reflection. If it's out front, it's a reflection across the x-axis. And what that means is that this v here is going to reflect down across the x-axis, and it's now going to look like that right there. So this graph that was here, that x, right, that's going to be gone. Similarly, my f of x is equal to the absolute value of x. I want to change that by a stretch of 3. When I ask you to do a stretch of 3, that means that it's going to be a value out in front of my absolute value. If it says to reflect over the y-axis, be careful of that. See this negative sign in front of my x? That then, not out front, because if I put the negative sign out front, that's a reflection across the x-axis. However, if I change this, I morph this into reflect across the y-axis, this is now negative x, like that. You see that? All right, so watch for that. Shifting right 1 generally is a negative value, right? -1, but because I factored, it's like you're taking that negative sign out. It's like saying the opposite of x minus 1 is realistically what we're doing. And what that becomes is negative x and then plus 1. So that's, I mean, yes, you can write it like that. Okay, if that makes you happy and it's like easier to understand, what we really are doing is we're saying the opposite, because that is my y reflection right there, that negative sign inside my parent graph. And so that would be x minus 1 and then absolute value. So that would be my parent function, reflection across the y-axis here, shifting to the right 1. And so what you're seeing here is just like that final graph, as if I took that negative sign and I distributed it through. All right. And so my graph would actually look like this down here, if you can see that right there. Okay. For this one right here, if I were to take x cubed, so this is f of x equals x cubed. Okay. So yes, there are some transformations on the final. Review those transformations, go back through and say, okay, what happened with those transformations and how did I do those? You know, parent graphs and stuff like that. Y equals x cubed is that graph that goes like this. If I were to reflect that over the x-axis, it would look like this, right? But at the same time, as if I were to reflect that across the y-axis, I'd get the same thing. All right, so some of these values, we call those odd functions, by the way, and we're probably going to get to those next semester. But okay, so if I were to reflect this across the x-axis, what's going to then happen is I would have a negative sign in front of my x cubed. A horizontal shift right would then take that value, right, and it would go x minus 3 quantity to the third power. And then a vertical shift down would take that and go minus 1. So this would be my equation for f of x after I did all my transformations. This is, again, a reflection over the x-axis, changes this outside. Where if it was a reflection across the y-axis, look up here, I would put a negative sign inside there, but I didn't because it's not y-axis reflection. All right, logarithms. Don't we love logs? Okay, your job is to sum and difference of logs. So you just have to rewrite this. It's pretty simple. You take this square root and let's make that into a half power, right? So this is going to actually be log of x to the fourth power over yz, and this is a big parenthesis, to the 1/2 power. I'm going to take that 1/2 power and I'm going to bring it out front. So I'm going to get 1/2, and then I'm going to say I've got now log of x to the fourth, right? Now remember, division means minus, so subtract, and then I'm going to keep those together for just 1 second. So that's going to be log of yz, all right? And so what's happening within this is this. You have to decide, this is minus this quantity, okay? Because that means that both of these are on the denominator. Okay, so I could rewrite that again, and then just for fun, I'm going to deal with this 4 and bring that out front in front of my log, right? So that's going to be 4 log base 10 of x, and then so this is yz. See that? So you have options. So you can either say this, and you can go minus the quantity log of y plus log of z, and quantity in bracket. See how it's minus that? Because these are multiplying, and multiplying is add. Or what I would recommend that you do, because you do have to simplify it, and yeah, guess what? That's not going to be a solution. So you're going to go 1/2 times 4 log base 10 of x, and then I'm going to distribute this minus sign. Minus log base 10 of y minus log base 10 of z. And so now, lastly, I'm going to take this 1/2 and distribute it. And so that's going to be, and it goes in the front. So that's 1/2 of 4, which is going to be 2. So I have 2 log base 10 of x minus 1/2 log base 10 of y minus 1/2 log base 10 of z. That's my answer. Okay. For this problem here, I want you to draw a sketch of the function. Now, I would go back to just a power, like y equals 3 to the x power, okay? Because a couple of things on an exponential function, right? This x plus 2 is actually taking my graph and moving it to the left 2. So that's going left 2 unit 2. That's left 2 units. This value here, this minus 1, is bringing me down 1 unit, okay? So I'm going to start off with the basis here, and I'm going to get, I'm going to plug, I've got x and I've got y. I'm going to plug in my two favorite points, 0 and 1. 3 to the 0 power is 1. 3 to the 1 power is 3. So I have 0, 1, I have 1, 3. So in graphing this here, all right, in graphing this, you're going to see, 0, 1, and then you've got 1, 1, 2, 3. 0, 1, 1, 3. You know it's exponential. You know the graph is going to look like this, right? Yes, you're going to have to graph this. You also should know that you have an asymptote, it's horizontal asymptote right here at y equals 0. That we call that HA, horizontal asymptote. So that's there. And now from here, you should know now you've got to go left 2. So now I'm going to take my points. I'm going to go left 2 and then down 1. So I'm going to go left 2, down 1. I'm going to go left 2, down 1. And also what happened is, guess what happens? Your asymptote moves with you, literally. So now we've got this happening right down here. So this is going to go with me, and I know that my new graph is going to go like this, okay? If I want to find my y-intercept, right, where is this crossing here? Because I just moved this off of my asymptote. So or off of the y-axis. So I could actually, finding the y, set x equal to 0. So 0 plus 2 is 2. 3 to the second power is 9. 9 minus 1 is 8, which means that at 8, 0, 8, that's where I'm crossing the x-axis. So that's a good, that's sort of like a good spot to know where you're going. Okay, so you guys got to, be smart, all right? You are smart, and use your calculators. Why not use your calculators? Depending what calculator you have. So for example, I'm going to pull out the, what is this? The TI-84. I would go to y equals, right? And I would plot my graph. What is it? 3 to the, there it is. And make sure you go in parentheses, right? This is what? X, what'd I say? I forgot. Is it plus 2? Yeah. So I've got x plus 2. So I go x, which is xt theta. So x, and then plus 2. Close that bracket, and then move yourself off of that. So you got to use the arrow key. And then what was that? -1. I think that was what it was. And then now I would graph that, right? Well, okay, there it is. And I know my window's a little bit weird because I know we were doing exponentials before. So I might just play with that. Bring that back down to minimum would be what? -10 down, maximum 10, minimum, I'm going to say minimum. I'm going to say -10. So I'm going to go -10, and my maximum, not 250,000, definitely not. Let's just say 10. And then I go back to graph, and there's my graph. Okay, so there's it. But what I would get from this, not only for the graph, because yeah, you have to graph these. And if it says, hey, which graph is this? If I give you a graph and it says, which graph is this? You better believe if I didn't know what that graph is, that I would actually plug in each one of those points into my calculator and figure out what graph it was. You be smart, you guys. All right, good test taking skills is what matters. I would go second table. And what this did, and so what this does is this gives me, like, I would go all the way back up. Where's my zeros? Okay, there we go. See these zeros? These are my points that I moved, right? These are the points that I just moved. I'm not going to see 0, 1, 1, 3 because I've transformed it. So, you guys can use your graphs. You can use your, what you have available to you. All right, so what I have here, what do I have here? Oh, just the graph. There it is right there. All right, log graphs, right? We have a log graph. This is log base 3. So that's that right there. You should know that log graphs go like this, right? You got your log graph like that. You can think of it as a y equals log base 3. Base 3, right? 3 to the y power equals x. Let's plot some points. Figure out where we're at. We have x, we have y. You plug in, on the last page, right? What was my exponent? My exponent was x. See the x up here? If I have an x as my exponent, it's exponential. I'm going to plug values in for x. Those are my first values I'm going to plug in. But if I have a y up here, see that? Base to cross equal sign, 3 to the y power, right? If I have a y up there, what I'm going to do is I'm going to plug values into the y coordinate. So I would plug in my two favorite points, which are 0 and 1. So 3 to the 0 power, 3 to the 0 power is 1. 3 to the 1 power is 3. So these are my points, 1, 0. So, right, I'm going to plot those points, 1, 0. And 1, 2, 3, 1, right? So I know my graph does this, right? I also have an asymptote at x equals 0. Here it is, right there. There's your asymptote. And the only thing really that we have going on this graph, we don't have any reflections, we don't have any of that, but we do have a horizontal shift, which means we're going to do a horizontal shift left 1, meaning that way. It's always the opposite, +1, right? So I'm going to go that way 1. So now my graph, move your asymptote, goes with you, right? Move it. It's not going with me. All right. Well, I guess it's parts of it are going with me slowly. All right. Oops. Oh, I guess I could have done that too, right? Okay, here we go. And then, so that's going to go, everything's going to the left once. So this point here, which was at 1, 0, is now going to be at 0, 0. This point, which was at 3, 1, is now going to be at 2, 1. So my graph has shifted to the left one value. Okay, and that's it. That's our graph right there. That's it. Okay, so you have a new graph. You can plot points. And, you know, fun fact, you all have access to calculators and Desmos. You guys can plug that value in. You know, do it. If you're unsure of doing these simple, like plugging in the points, use your calculator. You're allowed to use that. Okay. Solving these equations, all of these are going to be on the exam. You need to know how to solve equations. I would definitely look back over my log pages that we did. For this one right here, what you guys need to remember is that anytime you have a variable, right, x, up in the power place, up there, you're going to log unless you can get the bases the same. If you can get the bases the same value, you don't have to log, and you just have to do the math, right? Base 2 here, I can make this a base 2. See, 32 is 2 to the 5th power, right? So I'm gonna use that to do that. So we have 2 to the x minus 6 is equal to, this looks like it's 1 over, right? 1 over 2 to the 5th power. But in order to not log, and in order to set my exponents equal to each other, because my bases are the same, the bases have to be on the same level. So that means that this 2 to the 5th power needs to be brought up. So that's going to be 2 to the negative 5th. See that? But that's also to the 4x power, right? So bases are the same. I'm going to set my exponents equal to each other. I have x minus 6 equals 5 times 4, negative 20x. I'm going to add 20x to both sides. I'm going to get 21x. And that equals 6. And then we're going to get x equals 6 over 21. And that's my answer. And, oh, you know, hey, it's a final. Why don't you check your answers, right? I would plug in this value for x. I would plug it in here. 4 times 6 over 21, get that number, whatever that is. Go 132 to that. Use that hat button, right? To the parenthesis, that power. Definitely check your work. For this problem here, if your base, see log base 9, log base 9, log base 9, these are all the same value, right? I can actually get rid of those bases and log base 9 as soon as I combine anything that I need to combine. So this is a minus. So realistically, that would be log base 9 of x plus 6 all over x is equal to log base 9 of 2. Well, the log base 9s, those are going to go away. I end up getting x plus 6 over x is equal to 2. I'm going to cross multiply. I get 2x is equal to x plus 6. Subtract x, I get x equals 6. Be careful. This is one of those problems that you need to go back and plug those values in, because remember, you cannot have a negative argument. So this negative 6 needs to go in here. Or excuse me, it's positive 6. Is that a positive 6? Yeah, okay, we're good. 6 plus 6, check. 6, check. This is good. This is my solution. Because remember, if I got an answer and I plugged it back into my equation and it was not an answer, it would be kicked out of those solution sets and it would be on the outside. And it would be called extraneous. For this problem here, ln, natural logs are the same as logs, you know, whereas if you have the same value, I can combine these two. These I can combine. So I'm going to get ln of 2 divided by 3x plus 2, and that equals 1. What I can't do on this problem here, which I could do on this problem, is cancel those out, because I had logs on both sides of the equation, but I don't have that, okay? So what you need to do is you need to change this ln, and that ln is going to go to become log base e of 2 over 3x plus 2, and that equals 1. And by the way, 1 can be, I just want to, like, heads up, I don't know, can I say this? 1 can also be written as ln of e, right? That's also 1. Don't forget that. Okay, base to a cross equal sign. E to the 1 power. E to the 1 power equals 2 over 3x plus 2. What am I trying to solve for? I'm trying to solve for x, right? So I'm going to cross multiply. I get e times 3x plus 2 equals 2. E times 3x. So 3ex plus 2e equals 2. And get the x by itself. I'm going to come up here to the top. Get the x by itself. So I get 3ex equals 2 minus 2e. I want to isolate the x, so I'm going to get rid of this 3e. So x is equal to 2 minus 2e all over 3e. And you know what? Leave it. That's your answer, by the way. Okay? Leave it. Yes, you can change e into 2.71818, right? You can totally change that and get a decimal, but look at your solutions and see, is this one of my options? Is this one of my answers? Should I use that, right? You can. Okay, this one right here, love the fencing with the cows and stuff like that, right? You have 100 yards of tape. Oh, this is a tape. All right, to enclose a rectangular shaped ditch. If the ditch is X yards long, express the ditch's area as a function of length. Well, it's a rectangular shaped ditch, and we don't know what this length is, do we? No. But we know that what we do know is that this distance all the way around is going to give us 100 yards of tape. So whatever this length is, which we don't know, we're going to call it x. We know that y is also over here, and it's a rectangle. We're just going to call them x and y. That means that 2x's plus 2y's is equal to 100. It means that 2y's equal negative 2x plus 100. And it means that if I divide both sides by 2, I'm going to get y equal to negative x plus 50. And this is what my perimeter is for x. That's all my tape, right? And so this is my perimeter problem. And when you're doing these problems, okay, you need two values. You need the perimeter equation, or you need two equations. You need the perimeter equation, check, and you need the area equation. You have to have two every single time. Write that down somewhere so you don't forget. The area part of the problem is going to be x times y, all right? So to find the area, right, because they want me to express this as an area. So x times y, so that's x times y. Oh, I have y right here. So y times negative x add 50. And so this is going to be negative x squared plus 50x. And keep in mind, right, this is for the area, what you're realistically looking at, and you should know that your y-intercept here, you're at 0, 0, right? You should know that your graph is going to do this. That's what you should know, all right? And that when they're asking for the area, right, this is the max area in here, and which coincidentally, the max area also happens to be the maximum point, which is actually your vertex. And so I can use the vertex formula, right? This is my equation. I can go negative b over 2a. So negative b over 2a, a is negative 1. So what is that? Negative 50 over negative 2. And that's going to be 25. So 25. So that means that over 25, and by the way, that's half of my domain, which means that's 50. So my domain is 50, 0 to 50. In order to find that other value, right, I would go, the area is, I would go negative x. So negative, sorry about that. I just wrote that wrong. Hold on one second. Negative 25 squared plus 50 times 25. Okay, so that's what? 625 times, hold on. I can't see anything. Okay. I have a solution. Okay, so 25 times 25. So let's go out of here. Oh, quit. Let me get out of there. So we've got, I forgot the equation. That's called short-term memory. Sorry. All right. Negative 25 squared plus 50 times 25. All right. Negative. Oh, you can't make negative. You can't just type in negative on your computer. So we're going to go negative, what is that? 25 quantity squared. And then the other part is plus 50 times 25. Okay. So plus 50 times 25, and this should be simple. I know this is easy. 625. All right, so my answer, what is my answer? My answer is going to be 25 and then 625, which means that, drum roll, my maximum area is 625. That's it. Okay, do this again. A rancher has 360 yards of fencing in which to enclose 2 adjacent rectangular corrals. Horses and hogs, we don't really care. We know that, so it's a rectangle, right? And we've got horses, and we have hogs, okay? But the river forms on one side of the corral. Oh, okay. So let me redraw this because this is not our drawing anymore because now it's a river on the side. So let's make it a corral. Let's make that red. And then we've got horses here, right? And we got hogs here, and we've got a river here. And why is the river important? Because horses and hogs don't like to cross the river. I mean, some do. Anyway, we have so remember, we need 2 equations. We've got the perimeter equation, and then we've got our area equation, 2 equations, okay? Suppose the width is x. So the width, up and down, that's my width, x. But that's also x. Find the maximum area. That means this is y. And I only have one y because the other y is a river. So find the maximum area. Okay, so here we go. Perimeter is going to be 1, 2, 3 x's plus 1 y. And that's going to equal, and this is, I guess I should write it like that. Perimeter, this is the perimeter equation. 3 x's plus 1 y is equal to 360 yards. That's my perimeter equation. Solve that for y. Y is equal to negative 3x plus 360, all right? If you didn't have a river on this side, just note, this would also be y, and it would actually be 3x plus 2y is equal to 360, which means that I still would move the 3x over, but then I would still have to divide by 2, okay? But we don't have to do that for this problem because there's a river on the other side. Okay, so this is what y equals. And so I'm going to take what y equals, and I'm going to use that for the area formula. Area is just length times width, right? Base times height. So it's 1 of my x's times my y, x times y. So that means my area is equal to x times my y. This right here is my y. So we're going to go negative 3x plus 360. We're going to distribute that value. So the area equals negative 3x squared plus 360x. All right, so this is my equation right here. It is always going to be negative when you're finding the area under the curve, okay? Heads up. It's meaning 0, 0 here. It's going to go up. It's going to come down. I'm looking for the area under the curve, which is all of this stuff. Like I said in that last problem, which is also coincidentally my vertex point. So I want that value, okay? At some point, that's my value. This value down here, from here to here, that's my domain. Okay, that's my domain. All right? All right, let's use our vertex form shortcut. Negative b over 2a. So negative b, negative 360 over 2a. A is negative 3. So we have 360 over 6, which is 60, right? So 60. And then over. So that means I went over 60. So 60 is half of my domain, which means that if I ask for my domain is going to be 0 to 120, right? You should, okay. All right, now let's plug in 60. We get negative 3 times 60, quantity squared, plus 360 times 60. And that value is my area. So we have So we have 360, So we have 60 squared. So 60, okay, oh, I can see now. So I have 60 squared, which is just 3,600, times negative 3. And I get, what is that? That's not right. Hold on. 60 squared equals times negative 3 is negative 10,800. And now I'm going to add 360 times 60, and I get 10,800. Is that right? Let's see. So times 60, and so I guess I get 10,800. That's what it looks like. You guys check that answer. All right, so that means that my area, my max area, is 10,800. Now, you also can check your work. because you can take your graph, whatever this is, right, and you can find the vertex point. So what is that? Negative 3x squared plus 360. So yeah, you can totally use Desmos, but let's just have fun with this, and let's see what happens. If I were to graph this, f of x equals, let's see, negative negative 3x squared. Is that it? Yep. Okay, and then, oh, I don't want that. I'm going to go back up here. 3x squared, and then plus 360x, and then hit enter. Okay, I totally can't see my graph. So what I'm going to do is, this is so far up there, right? I can't even see it. But I do know that, what do I know? I know that I think my, what's that called? Domain was to 120. So what I would then do is I would, definitely, this is so small. I can't see the graph at all. Okay. And I know with, the other calculator, I can definitely change my values. And I know I could do that on here, but what I could also do is I could go to my table and I could find out what that value is also. And so like I would go to menu, maybe even analyze the graph. And if I want to find like my maximum value, I could set values. Like I could put X here, right? And then I could go all the way, keep going over. And I would, in order to find that maximum value, I know I have to go all the way over to 120, which I'm not getting by just finding this value. I'm not getting that, okay? So I would then, I'm going to in turn go to my INSPIRE calculator. I'm going to go y equals, or not INSPIRE, this is the TI-84. I'm going to rewrite this, and I'm going to go negative, I'm going to type in 3 x, I'm going to go negative 3x, so negative 3. I'm going to hit xt theta, and then squared, and plus 360, that's a 2. Hold on, go back and delete that value. So plus 360, and then type in x. And obviously when I graph, I can't see anything. But if I go to my window and I change that and I make my minimum, right, I make it 0, and I go my maximum, I'm going to make that 150 because I know that goes 0 to 150. For my minimum for y, I'm going to also make that 0, but my maximum, I think I got 10,000 or maybe 11,000. Let's make that. And let's see what my graph might, still can't see it. Looks like it goes way the heck up here. But that's what I would do. I would trace it. I would then go to my value here. And I would actually even go, because I know my max point is going to be at 60. So I would go even all the way up to 60. And if I wanted to, check what happened, there it is right here. And so that would be my max value. So you got to be careful on that. That, I think there was a mistake on this, so I'm not going to deal with that right now. But that's what I would do to get that max value. All right, is I would plot those points, use Desmos also, and see what works the best for you. Okay. Lastly, we are on, I think, maybe not lastly, matrices. You guys remember matrices? Okay, so talking about inverse matrices, all right? Yes, you're going to be asked a couple questions on inverse matrices. The way you find an inverse matrice is going to be 1 over the determinant. This is my determinant. And then the transpose, which is this. See, look at the variables. A is up here, D is here, D is here, A is here. Then in order to find the determinant, we're going to have to take these two values here, B and C, and we're going to take the opposite of those values. So that's the determinant, how you would write it. So if I wanted to find the inverse, and this is written to just find the inverse, okay? Both of these, find the inverse. So again, we're going to go 1 over the determinant. Now the determinant looks like this, right? So whatever 6, negative 8, 2, and 3 is. That's my determinant. And then I'm going to go times the transpose. And the transpose is going to take 6 and 3 and make that 3 and 6. And then it's going to take the opposite of 8, so that's going to be 8. It's going to take the opposite of 2, so that's going to be negative 2. And then I'm going to multiply this scalar value, which is just a number, times whatever's inside here. So I need to do a little simplifying. So the determinant is 6 times 3. Remember that? 6 times 3, which is 18. Subtract 2 times negative 18. So that, 2 times negative 8, which is negative 16. Yeah, and that makes plus. And so that together makes 34. And so this is going to be, yeah, they're not all going to be pretty. 34, and then this would be 3, negative 2, 8, and then 6. And then I would distribute that. That's what they want you to do. They're going to go, oh, that's 3 over 34. This is 8 over 34, which you would cancel, like reduce. This is negative 2 over 34, which would be negative 1 over 17. And this would be 6 over 34, which you could divide by 2. This right here is my solution. Let's do it again. Find the inverse. We're going to go 1 over the determinant. So 4 times 2 is 8. 8 minus 6 times 1 is 6. 1 over 2 times the transpose. And the transpose is going to be, flip those. So that's going to be 2 here, 4 here, negative 1, negative 6. So now all I have to do is distribute this 1/2. And so I'm going to get 1/2 of 2, which is 1. I'm going to get 1/2 times negative 1, which is negative 1/2. I'm going to get 1/2 of negative 6, which is negative 3. And I'm going to get 1/2 of 4, which is 2. That's my answer. And then I would absolutely check my work. 4, 1, 6, 2. I want to find the inverse of that. I'm going to use my TI-NSPIRE because I like that better to do this stuff. So I would go to menu. Let me get out of this. Escape. I'm going to go to calculate. I would go to my determinant little thing here, and I would click in that. Click it twice. I'm going to plug in my values. I've got 4. I've got 1. I've got 6 and 2. And then you've got to use your arrow key to get out of that. And then I want to use my hat key because that'll be to the negative 1 power. That's my inverse. And I think I just hit enter. And I get my answer, right? Is that what I got? 1, let's see. Did I get that? 1, negative 1/2. Let me check. 1, negative 1/2. Let's check. Let's just use that here. What do we get? 1, negative 3, and then negative 1/2. Yep, there we go. See how that works? I mean, like, whoa, that's so much easier, right? I mean, yeah, you should do that. You should check your work. Yes, you need to show your work. Yes, you want the right answer. Check your answer on your calculator, okay? So I want to solve the system. Remember our 2x2s. This, I'm going to ask you, I'm not going to ask you elimination. I'm not going to ask you substitution. I'm going to ask you Cramer's rule. Okay, so you need to know that. So we're going to go, remember how to do that. So we're going to go, we're going to do our little, these are not absolute values. They're Cramer's rule. So there's my x. And then for y, I'm just going to put that down here. All right, because that gives me a little bit more space. Okay, this value, this box, this is my box. Okay, and it goes down here. It goes 4, negative 2, and then 3, and then 1. And that's the box for both denominators. 4, negative 2, and then 3, and then 1. Now, if I want to solve for x, okay, if I want to solve for x, these two values right here go in the x column. So that's going to be 10, negative 5. If I want to solve for y, those two values go here, 10, negative 5, because it's like a point, right? X comma y. So the y's go in the y column, and then the x's go in the x column. Okay, anyway, so what goes here gets brought up from the bottom. So that's going to be negative 2, 1. And this is going to be brought up, so that'll be 4 and then 3. Okay? Now, all you have to do is cross multiply and subtract. So we're going to go 4 times 1 and then minus negative 2 times 3. So that's what? 4 minus negative, so that's plus. 4 plus 6 is 10. So that's 10. All right? And so do the same on top. Oh, by the way, 4 minus negative 6 is 10. So, like, I mean, yes, you should get the same answer. But if you're a little bit paranoid, I mean, there's no problem just, like, doing it again, right? Okay, 10 times 1 is 10 minus, and then this is this. 10 minus, is that happening? 10 minus 10. 0. 0 divided by anything is 0. So yes, x is 0. Okay, let's check what 0 we get here. 4 times negative 5 is negative 20, and negative 20 minus 30, is that right? Negative 20 minus 30 is negative 50, and negative 50 divided by 10 is negative 5. All right, so it says that basically my answer is going to be 0, negative 5. Okay, that being said, this is my final exam. I want to make sure I get the right answer. And so you better believe I'm going to plug my values into my equation to make sure I get the right answer. So I'm going to start with the top equation. I'm going to go 4 times 0 minus 2 times y is negative 5. Does that equal 10? Let's see, 0 minus negative 10, so that's 10. Does 10 equal 10? Yes. But, I very distrustful, actually, don't trust anybody. Well, maybe a few people, but anyway, I would do it again just for fun. Like, what's the hurt? 3 times 0 plus y. What's y? Y is negative 5. Does that equal negative 5? Yes, we have the right answer. So therefore, 0, negative 5, that's my answer. Check. We checked it twice. Okay. This one right here is asking you to multiply matrices. So what you have to remember about multiplying matrices is that the insides have to match, right? So if this is a 2 by 2, right, row by column, and this is a row, 2 rows by 2 columns, row by column, 2 by 2, these inner values have to match. They have to match, or you can't multiply. So if they do match, check, then what I get, my result, is the outside values, 2 by 2. So my result is going to be a 2 by 2, which means that's going to be just 2 by 2, 2 rows, 2 columns. And keep in mind, so if I had like a 2 by 1, and I'm multiplying that 2 by 1 times a 2 by 3, if these inner values do not match, right? If those inner values do not match, there's no multiplication happening. You're done. You can't do it, okay? All right, so row by column. Okay, so now in order to find this, so remember, this is row 1. So row 1, this is row 2. And then you go over here. I'm going to erase this now on top because we already know we can multiply these. This is column 1 and this is column 2. So you would think of, this is row 1, row 2. This is column 1, column 2. So if I want to find row 1 and column 1, I'm going to multiply row 1, that, times column 1. That's how you do that, okay? And then what you do is you multiply, add. So you're going to go 1 times negative 1. See this times this, plus 2, negative 2 times 5. So negative 2 times 5. So that's going to be negative 1 minus 10, which is negative 11. So that first value right here is negative 11. Boom. Okay, now I want to do row 1. I want this spot right here. Okay, so that spot, I'm going to move this. Oh, no, I'm not. This spot is row 1, column 2. So now I'm going to multiply row 1. It's already circled. So I'm going to multiply row 1 by column 2. Okay, so this is row 1 and this is column 2. All right, so row 1. So you're going to go across. So 1 times 2 plus negative 2 times negative 3, right? 1 times 2 plus negative 2 times negative 3. So that's going to be 2 plus 6. 2 plus 6 is 8. 8 goes here. For this spot, this is row 2. That's row 2, column 1. Okay, so now I'm done with row 1. I'm going to delete that or erase that. And you can totally write on your paper. I want row 2, and then I want column 1. And so I'm going to go row 2, column 1. Okay, so that's going to be 1 times negative 1 plus 5 times 5, which is 25. So that's negative 1 plus 25, which is 24. And then for the last one, right, I want row 2 and I want column 2. And so I'm going to go 2 times 1, which is 2, plus, and then 5 times negative 3. So that's going to be 2 minus 15, which is negative 13. And so that's my answer. Okay, so yeah, that would be awesome if I could actually check that. Let's see. We got 1, negative 2, we have 1, 5, we have negative 1, 2, and we have 5, negative 3. Let's see if my calculator actually will do this. Just for fun, right? Why not? Check. Okay, so I'm going to go new document, and I want to calculate. So I'm going to go with my I'm going to fill this in here, and that's going to be, and let's see, so we've got 1, let's see, -2. Let's see, that would be a 5, and then over here would be a 1. Oops, not a Q, a 1. And then let's put another one of these. I'm not sure if this will actually work, but well, let's just see. Let's see. I've actually never done this before, so I'm going to try this. So -1, and we've got a 2 here, and then we have a 5 here, and we have a -3. And I would make sure that my cursor is outside. Is that what I got? Let's see. Let me do a screenshot of that and see if that was what I got. Was that it? -11, 8? All right. I would totally use this. Okay. So my next problem is solve the system by inverse matrices. All right. So for this problem, solving this by inverse matrices, this is what you're looking at. I'm going to look for, again, we are going to look for your work. Yes. Completely fine to check your work. Yes. All right. So inverse matrices. All right. Okay. Let's see. I start off by this box here. There's the box. You're going to plug that in. So you've got 5 here, 2 here, 1, and 1. See the ones in front of there? That's what you're using. All right. And then you've got X here, Y here. Okay. And then that equals, and then you've got your little values on the right, which are 11 and 4. Okay. Now, to solve this by inverse matrices, okay, we actually want to isolate. We're trying to solve for X and Y, which means that we want X and Y by itself. All right. So that means that this value, this matrix here, I'm going to move over to the other side. By doing that, right, just like tangent, right? If you had like tangent of an angle equals, I don't know, some number, 5. In order to get theta by itself, right, you move tangent over to the other side. By doing that, that was what? Arctangent. Same thing. That's the inverse. That's what we're doing. We're doing that same exact thing, okay? And so what happens now is that this 5, 2, 1, 1, when it comes over, it does go in the front. Make sure it's in the front. And it's an inverse, and that's just 5, 2, 1, 1. And then over on the right-hand side, you still have this 11, 4 over there. All right, now, a couple of things. Number one, this is an inverse, and we did this like 2 slides ago, 3 slides ago. And in order to find the inverse, remember, we're going to find the determinant. So let's leave this here, and that equals 1 over the determinant times the transpose times 11 over 4. I am totally looking for this on your final. Make sure you show your work. Now, the determinant is just 5 times 1, which is 5, right? Minus 2 times 1, which is 2. 5 minus 2 is 3, 1/3. So this is 1/3. So this will be 1/3 times this value, whatever this is, times this value right here, which is 11, 4. So watch. Right. So what am I doing? Oh, yeah, the transpose. So the 5 and the 2 can't flip. So that's 1, 5. This becomes -2. This becomes -1. And actually, I don't need to keep this here. Because what you're going to do first is this right here, this 1/3, multiplying that through, that is way last, okay? That's last, all right? So I'm going to multiply these 2 terms. Now, I got to make sure I can multiply them right. Think. This is a 2 by 2, and this is row by column, row by column. This is a 2 by 1, which means do these match? Yes, check. So what am I going to get? I'm going to get a 2 by 1 when I multiply those out. I'm going to get a 2 by 1. Okay, so that means that this is a 2 by 1 now. So here we go. 1, so I'm going 1 times 11 plus, so I'm going row by column. 1 times 11 plus -2 times 4. So that, what is that? 11 minus 8, 3. 3 is awesome. Okay, let's do it again. Row by column, row by column. So we go -1 times, okay, -1 times 11 plus 5 times 4. Do you guys see that? Row by column. So I'm going negative 1 times 11. So I'm multiplying those two and then adding 5 times 4. So that makes negative 11 plus 20, 9. And then 9 goes here. So cool. And then you're going to go x, y. And so now I have to distribute 1/3. So that's like 3 times 1/3. What's 3 times 1/3? 1. So that's 1. And then it's 1/3 times 9, which is 3. So therefore, everybody, my intersection point is 1, 3. And of course, I'm going to check my answer. And yes, I would plug it in, like 1 plus 3 equals 4. But, you know, why wouldn't I plug this into my calculator, since we know that these calculators are amazing? Okay, so we would get, what is the original question? It was like 5211. I think that's what it was. Yeah, inverse, and then 11/4. Okay, so I would go back to my calculator, and yeah, the TI-84s do this. It's on our slides. And it's under, you got to look under, I think it's math, and then you got to find matrices, and then you just type that in like that, okay? So for this problem, I'm going to do this again. I'm going to go to this little spot here, and I'm going to make this 5. Oops, not there. I'm going to make this 5, and then this value is 2. This value is 1. This value is 1. And I'm going to go outside of that, and I'm going to go use that hat function, which is this thing, and then I'm going to go to the -1 power, so -1, check, go over, and then I'm going to put in a 2 by 1, but I remember that I only have that option. Do I have a 2? Oh yeah, I do. It's right there. Okay, so a 2 by 1 is 11, and then go down, and then I think it's 4. Go over, enter, 1, 3. Don't you love calculators? Okay. All right. So happy campers we are. Here we go. All right. 3 by 3s. Okay. Cool. Remember our 3 by 3s? Okay. Expanding a row or column. Let's do this for fun, right? Because that is fun. Expanding a row or column. Expanding a row or column. That's not the shortcut where we're rewriting that, okay? We are expanding a row or column. So in order to expand a row or column, you got to remember your array, right? Same, opposite, same, opposite, same, opposite, same, opposite, same. So what this means is if I chose the top row and I chose to expand it, it's going to be 3 times a determinant. This is a -1. So -1 times a determinant. And then that's plus 0. Oh, I love that because that's gone. Okay, so, and the array right here, if I'm expanding this, is going to be, this means same, that means opposite, and that means same. So it's going to be the same sign, don't touch it, opposite sign. So now this is now a plus. Now it's a plus. And then this is, we don't care because 0 is going to, goodbye. All right, so we're going to expand the first row, so we're going to cross this out. Okay, I did a good job of crossing that out. So we're going to cross that out. And what's left is what goes in here. So we have -3, -1, 0, and 4. Okay? And so now I've got to cross out the -1, or which was the 1, right? So this right here, that's gone. And so what's left is 2, -1, and then -5, and then 4. And we don't care about 0 because 0 is not going to count, okay? So we've got 3 times, now you got to cross multiply. So it's going to be 3 times, that's going to be -12, and then minus 0. Plus 1 times, 2 times 4, 8 minus, and then this is this value, what is that, 5. So 8 minus 5 is 3. We have 12 minus 0, so -12 times 3 is -36. -36 add 3 is equal to -33. So this determinant value is -33. You just need to keep that in mind. Absolutely, there is a lot of error that you can make at this point, and your calculator for sure is your best friend at this point. And I do actually believe that Desmo's scientific calculator will do this as well. I know, I think it was Alex that was telling us about that, and that was gave us the idea for that. So let me go here. Let's go to new, and I'm going to go calculator again. And so for this one, I want the determinant. I don't want the matrix. So let's think. We're going to use DET. That's what you'd write. Type in that. Okay? And then you're going to go to your determinant, but I want, is it a 3 by 3? It's a 3 by 3. Check. But I don't want the matrix. I want the determinant, right? So that's why I've got the determinant there, because determinants are scalar. That's going to give you one value, where a matrix is not. That gives you that value, that stock like that. Okay, so we're going to go 3, let's see, -1, go over 0. I think this was a -1, down was a 4, going over, I think, let's see, this value was a 2. We had a -3. You guys have the slides, so I posted those. So you can look at the -5, and you have 0. All right. Uh-oh. What just happened? Didn't like something. I don't know. Error. Oh, I'm missing parentheses. Oh, it didn't like that. Okay. Uh-oh. Okay, thank you. Let's see. Put in parentheses. Oh, there we go. Maybe I'll like that. Yes. Okay, so that's -33. Oh, let's see. Did I get a -3? I did get -33. That's good. See? We're doing good. Now, this was the shortcut method. This was just where we rewrote the first 2 columns, right? These are columns. So you went 6, 0, -9, -2, 1, and 3. And so rewriting the first 2 columns, right, after I did that, I would just go like this. 6 times 1 times -12. So 6 times 1. Okay, hold on. I actually would do this on my calculator, I think. 6 times 1 is 6, right? And then times 12 is 72. So that would be parentheses, -72. And then I would go 2 times 4 times 9. And that's going to be, what, 8 times 9. That's 72, but that's negative. Right? Yeah. Ooh. Okay. And then, so that's -72 plus -72. And then we would go this, which is 0. So that's gone. And then minus going backwards. So that would be, but inside the parentheses, you're adding, and it could be a negative number. This is adding a negative number. So this would be -9 plus 1 times 8, which is -72, and then plus 3 times 4, which is 12, times 6. And what is that? Negative, I don't know. Let's see here. 12 times 6, that's 72, but that's -72. And then plus 0. Again, boy, this looks like it might not even, what is this? -72 and -72 is -144 minus -144. Oh boy, that looks like I'm getting 0. I would totally check this answer, right? I would absolutely check this for the determinant. And let's just do that. We've got 6, -2, 8. We have 0, 1, -4, and then -9, 3, and -12. And the reason why I would check that is because if I don't get the right answer, which you have to show on your calculator, that you show on your work that you did get it right, yeah, you would not get credit for the problem. Okay, so you got to be careful with that. We're going to be very, very specific about that. If you don't show your work, you don't get credit. All right, so this time I did put it in a parentheses. Okay. And the values are going to be, we've got 6, we've got -2, and we have 8. And then we have here 0, and then 1, and then -4, and oops, not there, right there, -4. And if you already know how to do this, please fast forward. No, not a problem. -9 and 3. And then -12. All right. And I'm going to go outside of you got to make sure you're outside, hit enter. Oh, I get 0. Good. Okay. We're happy. All right. Next. And we're going to go down. Okay. So this, I'm going to ask you something like this. This is finding X. And I'm going to ask you to use Cramer's rule. Okay. So in order to use Cramer's rule, you're going to either do X, Y, and Z, depending on what problem you get. Okay. So X equals. And so this is the big deal. That's what I'm looking for. So you see that? Yeah, no, I'm not gonna do that. Okay, so this is this right here, x, y, z. So we've got 1, 1, 1. We have 2, negative 1, and we have 3. We have 3, we have 2, we have negative 1. And if I'm solving for x, these values right here are going to go in x. So that would be negative 4, we have 1, we have 4. And then everything else gets brought up. So this would be 1, negative 1, 2, and then this gets brought up to 1, 3, and then negative 1. And then, you know, Cramer's rule, now you have an option. You can use the shortcut method, or you can expand one of the columns, right? And I know what comes to mind is the calculator. And at this point, if you set it up, yeah, you got to set this up, and then you're going to solve for x. And yes, I would definitely check with the calculator. Absolutely. And I know x is 3. I've shown you both ways to do it, whether you rewrite the first two columns like this, 4, 1, 4, 1, negative 1, and 2, right? And you multiply across, and then you subtract, or you expand one of the columns, right? You expand rows or columns. So if I expanded one, the top row, it's 1 times that value, plus 1 times that value, plus 1 times that value. But don't forget, when you expand that column, right, or that row, you have to use the rate, which is same, opposite, and then same. And so, which is completely fine, right? If I was crossing out the 1, negative 1, 3, 2, negative 1, that's what I'm talking about. And then, of course, you would just move that to the next value and get the next numbers, right? You would get 2, 3, and then 3 and negative 1. And lastly, if I move this all the way over to the right, the values that are left in the box are 2, negative 1, and then 3 and 2. And, you know, work that out. I already posted the answer. The answer is 3 to get x. It's not the whole thing. I'm not asking you for the whole thing. I'm asking you for just that value, okay? I will say that I'm going to show you how to do this really quick on the TI-84. It looks like I've got 1, 1, 1, 2, negative 1, 3, and 3, 2, negative 1. That's negative 4, 1, and 4. Because this works for a 2 by 2, 3 by 3, whatever. So we would go, I'm going to go second, quit, all right? Clear. All right, so for this matrix, so we're going to go second matrix, okay? And you got to figure out, okay, this looks like it's a 3 by 3, right? So we're going to go 3 by 3. I'm going to hit enter. Oops. That's not right. We're going to go second, do this again, matrix. I've got to go arrow over to the right to edit. And I'm going to edit my 3 by 3. So I'm going to enter, I'm going to go 3 by 3. And if there's no value there, you're actually going to type in the number 3 and then number 3. And this is, oh, looks, that's the same answer. But 1, enter, 1, enter, 1, enter. And then I've got 2, enter. And then I have a negative 1. So you've got to use the negative here. Negative 1, enter, and then 3, enter. And then on the bottom, it's going to go 3, enter, 2, enter, negative 1. So again, that's negative 1. And you have to enter through that. So now what you do is you go quit. You go second, quit. And you've got to remember that you've saved that under A. So now I'm going to go second matrix again. And remember, the second column is a 3 by 1. So now I'm going to go down. I'm going to go edit. And now I'm going to type in a 3 by 1. So if that's not there, I'm going to go 3, enter, 1, enter. And my numbers here are negative 4, enter, 1, enter, and then 4, enter. Okay? All right. So now I've got to quit. So I go second, quit. All right. So remember, we put it under A and B. So I'm going to go second matrix and see where it says A, hit A. Now I've got A. Now remember, this is just like this is a 3 by 3, but it's just like the inverse that we did. So this is A inverse. So this is going to be the hat button, negative 1. Yeah. And then arrow over because I got to come back down. Arrowing over on a TI-NSPIRE is different. You get a different, it's different. This one will bring you back down. And then you're going to go second matrix. And now I got to roll down to B and enter. This should give me my answer. 3, negative 4, 3. Check. So that's my answer. And I only had to solve for X. So, you know, you're on a time limit. You got to be careful. All right. So we're done with that. That's awesome. check. We got that. Okay, next problem. Next type of, oh, this is just reminding you of using determinants. And I remember that I almost forgot the parentheses. So it's really important that when you do that, you know, you use the parentheses to solve that. And this is a 3 by 3. Don't forget, right? You can use, this is 3 by 3 times a 3 by 1. You're going to see a problem like this that is asking, oh gosh, we're almost done. That is going to ask you to simplify, solve for x and y. Use your brain here. Let's see, y, these have to be in the same spot. Y equals 2. You're done with y. Y equals 2. I mean, definitely you can use this part where you say y plus 1 equals 3, but you still get y equals 2. For this one, I can just say x plus 1 equals 11. I don't have to say 5y equals x, but I can. So that means x plus 1 equals 11, which means x equals 10. Done. Next problem. We are back to lines, and you know, this is like totally one of my favorite, and I know, I think you guys remember I had such a good time. There's Venom. We love Venom, and Venom is crazy, and oh, can't get this one going. Maybe I can. Let's see. Who is fighting? Oh, Captain America. All right. Right on. Okay, this we're solving systems of linear equalities. You are going to be able to graph and be able to come up with an equation. So graphing the first one, oh my gosh, where's my y? I think I lost my equations here. Oh, this one just says 2x. This is very simple. 2x is greater than or equal to -1. X is greater than or equal to -1/2. So basically that's saying if I had a graph, let's say this is, that's positive. Let's say this is -1/2. That means that my graph, right, x equals, so this is my graph of x equals, and it's a solid line because it's an equals, and it's saying it's greater than, so that's shading everything over here to the right. This here is saying 3y is greater than 6, so y is greater than 2. So that means that's a graph of y equals 2, but it's dotted, okay? That's dotted. This is y equals 2, and it's saying y is greater than, so it's everything shaded above this, but the only thing that's double shaded is this area in the top right. So all this stuff over here, that doesn't exist. So you're thinking about only the part that is double shaded would be your answer. For this next problem, here, you're going to be given an equation, and you're going to have to come up with the equation. Now, you're looking at this. This is my double shaded. This is it right here, okay? That's the double shaded. So you have two lines. We have one dotted, and we have one solid. You have to come up with the equations for those lines, all right? This one, I can't tell where this is going, but I do see, actually, that we have 1, 2, 3. We have a point here at 3. So if I start with y equals mx plus b, right? So y equals, I know that b is going to be 1, 2, 3. All right? So far, so good. I also know that I'm shading down. See how it's shaded down? So that means that this equals is not actually an equals. It's less than, but not less than or equal to because it's a dotted line. And we also know we have an x here. All I need is my slope. So I need to find another point. It looks like there's a point here, and then there's a point here. So what's my slope? Up 2 over 1. So this would be slope of 2. So 2x plus 3. So this is this equation right here. You are going to have to do this. You have to be able to do this. The second line is here. It looks like I'm crossing at 1. So I start with y equals mx plus b. I'm crossing at 1. That value is here. It looks like for this line, it's solid, and it's shading above, right? So that's going to be greater than or equal to solid line. I do have an x. Now I need my slope. So for this line, it looks like it's down 1 over 1. Yeah, it sure does. So my slope is negative x. So these are my two equations for my line. You have to be able to do that. I think it's the last section, I'm pretty sure. Linear programming, you guys, you need to be able to do this. You need to be able to come up with linear programming, basically a system of linear constraints, that's what it is. They're going to give you 4 or 5 different constraints. Your job is to find the maximum value that yields you the most profit. Okay, and so we did this one in class, and I'm just going over this. pretty quickly because you guys can go back through this. Clothing problem, student council decides to raise money. They want to sell imported clothes. X is the number of shirts. Y is the number of dresses. The import order must meet the following requirements. These are your constraints. The total number of shirts or dresses must be at least 10. What I would suggest that you do right now is to pause the video, write these values down that you think write them down, write your constraints down. And then on the next page, I have the solutions and I want you to check them. That's it. The number of shirts must be between 5 and 27, inclusive, which means they include 5 and 27. The number of dresses must be less than twice the number of shirts, but at least 1/6 the number of shirts. 4 times the number of shirts plus 3 times must be at most, not more than, right? At most, it's that value or less than. So here's my constraints. Check your work. You've got the total number of shirts, that's X and Y, or shirts and dresses must be at least 10. So greater than or equal to 10. Done. You're going to solve for Y, and then you're going to basically graph that function. The number of shirts must be between 5 and 27. So this is one of your word problems at the very end. So all of your test is going to be multiple choice. And at the very end, there's 5 or 6 problems where you have to actually do this stuff. One of them is this. One of them is exponential. One of them is linear modeling. This is what we're doing, right? This is the number of shirts must be between 5 and 27 inclusive. See how it's equal to. The number of dresses must be less than. These are my dresses, twice the number of shirts, and then at least that's greater than, more than that value. 4 times the number of shirts plus 3 times the number of dresses must be at most 135. Solve for Y. Solve for Y on all of these and graph your results. You're going to get this value. Now, on this problem right here, I don't think they ask you for a profit margin. But I would then, if they did, okay, I would be looking at this point, and probably this point. I might plug in this point, maybe, but you would plug in all those points to the value. All of those points I would plug in to my profit equation. Okay, and I'm going to go over one of those in just a minute. CB radio manufacturing. We did this in class. You can look at your slides, you can look at the notes, but you have got to be able to write the inequalities of the restrictions given. Okay, so I would again pause the video, write down all the constraints that you think that you can do, and then on this page here, I would check them. Okay, and these are all my constraints. The assembly line can produce no more than 25 breakers, so that's less than or equal to 16 good buddies. So that's and we've done this in class, and we did maybe 10 questions in class, and this is just 2 of them. You guys should go back over all the questions that we've done, even the Jamboards. Remember the Jamboards we did with this too. They can spend a total of this, so go back through. You guys should be able to do this. This should happen. Once you get that, your job is to find the optimum point. So you have to graph these. One of the things that you need to watch for, of course, is how you're labeling your axes, all right? So be careful what depends on what, right? And then just find that maximum number. For this problem here, we got to find the optimum point. So we had all these different values here. In this case, the optimum point was between I and II, which was this value right here. So this value right here was our optimum point in this problem, and that gave us the biggest profit. Okay, and notice that down here, I don't know if you can see this, but down here they gave us that maximum profit, and that's where that point is. That's where that value is, over 8 up 23. That's the value that gave us the highest value for the most money for our efforts. This is where we finish that problem. It says the company makes a profit of $40 on each breaker, $20 on each good buddy. Write an equation expressing the dollars as your profit. So you've got your equation. You've got 40 breakers, 20 good buddies, and then you take that point that you did that gave you your maximum value on the other side, and you plug it in. And so what a lot of the questions were, I remember as we were doing this last when we were doing this through the chapter, was how do I know which point to plug in? Well, you have this profit statement. This is your profit statement. Okay, you need to get this value. This is really important that you get this first. Get that first. And then go back and look at all these intersection points, right? We got this point here. We have this point here. And I would take those 3 points, all 3 of those points, and I would go to my profit statement, which is right here. And I would plug in all of those points. And whichever gave me the maximum value per day is the point that yields me my maximum value. That's the max profit. And so that's how you do it. So again, get your profit statement. Plug in the points that you think might fit in there. And then whatever value gives you your maximum profit, that's the value. That's the one that you want to use. Okay? All right. The last question is going to be an exponential growth problem. And this is expected. You guys, you know how to do this. We did this in class. We did this like numerous times. There's 1,000 mosquitoes initially right there. What am I looking for before I see that? Because I know that I've got 0, 1,000. That's one of my points, right? But unless I see that it varies exponentially, this could be my 2 points, right? After 3 days, there's 1,800 after mosquitoes after 1 day, and I had started off with 0. So we know this is exponentially, but remember, these are just points, right? If I don't say that this is varying exponentially, my 2 points, I could just make those into a line. I do not need to make those points into an exponential equation unless I know that, or I'm told, like either I do that my add multiply property, and I know it's exponential, or I'm told that it's exponential, and here they're telling me that. Our job is to come up with an equation, and again, depending on what calculator you're using, this will depend on, what our equation is. I'm going to do this by hand first, okay? Because we have our equation, which is f of t, or t is for time, is equal to a times b to the t power. If I do this by hand, my a value is 1,000, because automatically we know that y, which is 1,000. So we're going to go 1,000 is equal to a times b to the t power. This is t. This is t. This is f of t. And that means that's 0. B to the 0 power is 1. 1 times a is a is 1,000. Okay, so we already know that. So in our equation so far, we know a is 1,000. That's going to be 1,000. Now to find b, I'm going to take my original equation, I'm going to plug in my second point. This is y here. So I'm going to go 1,800 is equal to a. Oh, a is 1,000. And then times b. We don't know b, but we do know this is b to the 1 power. So I don't have to square root it. I don't have to do any of that, right? I just have to divide both sides by 1,000. And 18 divided by 10 is 1.8. So I know that b is equal to 1.8. Excuse me. And so finally, we know that f of t is equal to a, which is 1,000, times b, which is 1.8, to the t power. And so this isn't like that hard to come up with the equation by hand, of course, right? What do we have? 0, 1,000, and we had 1, 1,800. So it just depends on, the calculator I want to use. I can go clear this. I'm going to go to y equals. I'm going to clear this, and I'm going to say, I'm not going to go to y equals. I'm going to go to stat. I'm going to go edit. So I'm going to click on edit, enter. And if I have values that are already there, remember I go up, I clear, I come back down. I go up, clear, I come back down. All right. So now I'm going to plug in my values. I have just 2 points, 0, enter. And then 1, enter. I'm going to go up here. 0 was 1,000. This was 1,800. And now I go back to stat. And I go over to calculate. And I go down to where it says exponential regression. Right there. Exponential regression. Hit enter. That gives me this. Enter, 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 enter. There's my equation. A is 1,000, B is 1.8. We have our exponential regression. We have our equation. The other option to do this, again, this is with my TI-NSPIRE. I would go to Oh, I have to exit this. Hold on. Escape. Okay. No, I don't want to save that. I'm going to go new. I'm going to go down to list and spreadsheet, and I'm going to call this something because this differs from the TI-84 because you have to name it. So this is X. This is f of X. Okay, and then my 2 points are going to be 0. We had the 1. I'm going to go over, what was it, 1,000. And then down is 1,800. Okay, so what do? I go menu. I go down to statistics, stat calculations, find exponential regression, click. Then it says, oh, now I just have to name it. I think for X, we used X. I know, tricky. And for Y, I used f of X. And that's, forget everything else. Just go, okay. And here's my equation. Now, this is kind of cool because they've got A is 1,000, B is 1.8. And that's my equation, A times B to the X power. But just keep in mind also that the why I like the TI-NSPIRE is just because it's cool too. But the R value is 1. And remember, an R value basically tells you whether or not, your equation is accurate, right? So like if your boss later on in life is telling you, hey, would you stake your, you're telling them that according to this data, this is exponentially increasing like really, really fast. And here's the equation. And in this many days, this is what's going to happen. And your boss is asking you, are you sure? And that R value is basically going to say, yeah, I'm positive that this is happening. Okay, so we're going to go back to the slides, and just says what's the size of the colony after 3 days. You totally can do this by hand too. I mean, it is not a requirement that you do this like this, because the add multiply property. That 0, 1, and this is 1,000, and then this is 1,800, and then to get to 3 days, right? 2, 3, that's there, right? I just have to find 2 days and then 3 days, and then to get to the next value, right? You just basically took 1,800 and you divided by 1,000, and what that did was that gave me my B value. So now I know that B value is 1.8. So realistically, I can go 1,800 times 1.8, and I'm going to get the next value, which is 3240, and then take that number and times 1.8, and that's going to give me my next value, which is 5832. So 5832, and then at that point, I can just, okay, so like after 3 days, I'm here at 5,800 mosquitoes, awful, or I could go 1,000, right? I could plug in that 3 here and go 1,000 times 1.8 to the third power. And I'm going to get the same answer. I'm going to get 5832. Totally fine. The last part of it, it does say, and I'm going to ask you this, when am I going to reach 10,000 mosquitoes? And I know that if I keep multiplying by 1.8, I'm going to get to, 10,000 or right around there. But I am asking you to actually be able to get that number and show me your work for that. So what I would do is I would suggest you that you know how to do that, right? So I would go 10,000. So I'm going to take 10,000 equals 1,000 times 1.8 to the t power. And then you have to log, right? You're going to divide both sides by 1,000. So divide by 1,000, and then that's 0, 0, 0. We get 10. Hey, so 10 equals 1.8 to the t power. Remember, right, that you're going to go t log 1.8 equals log of 10. Now, be careful with this too, because what's log base 10 of 10? 1, right? So realistically, this is t equals 1 divided by log of 1.8. And so, just get that value. I don't know, what is that? Log, okay, I'll do it. So that's going to be 1 divided by, or actually, I'm just going to go log. So I'm going to go log 1.8, and that equals that value. Then I'm going to go 1 divided by my answer, because I don't like to put in parentheses, is 3.9. So that's like 4 days. So 3.9 is 4 days. So I'm going back over here. So basically what this is telling me is on my 4th day, or this 3.9, right, I'm at 10,000. And so this is like a mosquito epidemic. Mosquito-demic. I don't know. Okay. Anyway, so that's how you would do that. Okay. So that's it. Those are all the types of problems. You guys are going to have 105 minutes, or like basically almost 2 hours, an hour and a half to complete your final. I'm wishing you the best of luck. You're already doing the right thing by watching this video, so good job on that. And practice, practice, practice. Go look over the slides. Look over the class slides. Look over some of the videos, the review videos. Look at, make yourself familiar so that if you see a problem, that it's not going to be a shock to your system and it's not going to cause you to waste time. So wishing you the best of luck. All right. Have a great holidays. I'll see you on the final exam day. And thanks so much for watching. If you like this video, please like it. Okay. All right. See you soon. Bye.